This video goes over probability and statistics questions that could show up on the TSIA math. Take a moment to look at these vocabulary words. If you're unfamiliar with any of these, look up what they are and what they mean. Mean, median, and mode. Mean, median, and mode are all ways to attempt to describe a set of data. These are also known as your one-variable stats. The mean is the arithmetic average of the values found by adding up all the values and dividing by the number of values or terms. Median is the value where 50% of the values fall above it and 50% of the values fall below it. To obtain the median, rewrite the data in order from smallest to largest. Counting towards the middle from both ends, the median is the number in the middle. If there is an even number of entries, there will be two middle numbers. Then you would take the average of those two numbers. Mode is the value that occurs the most often. Here's an example of finding these one-variable stats. Suppose 10 students took a test and got the following scores: 83, 87, 92, 78, 83, 85, 95, 50, 90, and 81. The mean is 82.4. You would find this by adding all those numbers together and divide by the number of terms. And it says that there was 10, there's 10 things here. We're going to divide that sum by 10. The sum would be 824, and if we divide that by 10, that's how you get the 82.4. Next, it says the median is 84. Before you do that, you want to order it from least to greatest. When we have them in order from least to greatest, we count off the same amount each side. And then notice that we have that 83 to 85 in the middle. The middle of 83 to 85 is 84. The mode is 83, which occurs twice in this series. It's the only one that occurs more than once, so that's why that is the mode. It's possible to get more than one mode. The mean is a little lower because of the one low score 50, an outlier, which is a number that varies widely from the rest. The mean will be skewed more by outliers than the median or the mode. So some key things to remember here is that these measure how the entire data clusters around a central value. Median is not affected by outliers, but the mean, the average, is affected. You want to order the data from least to greatest first, and if there are two numbers in the middle, find the average between the two to find the median. Try these two examples. What is the median of the following 7 scores? 42, 67, 33, 79, 33, 89, 21. Also try this example. A history class is made up of 12 10th graders and 9 11th graders. The 10th graders averaged 77 on the midterm exam, and the 11th graders averaged 91 on the midterm exam. What is the average grade on the midterm exam for the entire class? On the first example, remember you want order them from least to greatest first, and the median is the middle. The answer to this first example is A, 42. There's 3 terms on the left side and 3 terms on the right side, and then 42 is in the middle. The answer to the second example is B, 83. There's 12 10th graders and there's 9 11th graders. The 10th graders had an average of 77, so we multiplied 12 by 77. And then we're going to multiply the 9 by 91 since that's the average for the 11th graders. There's 21 students altogether. Add those up, divide by 21, and you get 83. Quartiles and percentiles. Quartiles and percentiles are ways of describing where a particular value falls in a data set. The lowest value of a data set is 0%, and the highest is 100%. A data value in the nth percentile means that it is somewhere in the first n% of the values. If it is at the nth percentile, then n% of the data is below that value. Quartiles divide the data into 4 ranges. The lowest quarter of the data is the first quartile. Between 1/4 and 1/2 is the second quartile, and so on. Think about this. Would you rather be at the first quartile or the third quartile for a test score? Consider these values, 10, 20, 80, and 90. The first quartile would be at 10, the second 20, the third 80, and then the last one 90, the fourth quartile. It's better to score an 80% than to score a 10%. Types of counting. If it asks questions such as what are the total choices in something, or how many ways can you order something, you want to look at some key words. You want to know if the order matters, which would be permutations, or if you want to see if the order does not matter, that would be combinations. From there, also determine if it has repetition, if you can replace each value, if it's on a spinner, for example, or if you cannot replace them, such as people in an officer position. The way something could be arranged would be factorial. In factorial just means that you take each integer from the one that's listed and multiply them from that number all the way to 1. The counting principle is finding the number of choices of something. Conditional and independent probabilities. If the outcome of event B depends on the outcome of event A, the probability of event B is said to be conditional. For example, the probability of drawing an 8 from a standard 52 card deck on the second draw will be different depending on whether an 8 was drawn on the first draw. That is an example of without replacement. In contrast, if events A and B do not affect each other in any way, the probabilities are independent. If 2 standard dice are thrown, the outcome of one die is independent from the other and the probabilities are independent. That is known as with replacement. Probability rules. We have the addition rule. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. If A and B are mutually exclusive, you have the probability of A or B equals the probability of A plus the probability of B. Multiplication rule. The probability of A and B is equal to the probability of A times the probability of B given A, or the probability of B times the probability of A given B. If A and B are independent, you have probability of A and B equals the probability of A times the probability of B. The complement rule is the probability of A complement is 1 minus the probability of A. Hypergeometric is the number of marked individuals in sample taken without replacement. We have M given X times N minus M given N minus X divided by capital N given lowercase n. A binomial distribution. The number of successes X in n fixed trials. N given X times the probability to the X power times the complement of the probability to the N minus X power. If you see OR, that's going to mean that you're adding those probabilities together. If you have an AND, that'll mean that you're multiplying those probabilities together. Let's look at some examples. This one is addition rule, not mutually exclusive. A litter of kittens consists of 1 gray female, 3 gray males, 1 black female, and 2 black males. You randomly pick 1 kitten. What's the probability of the kitten being gray or female? So first you want to find the probability of selecting a gray kitten. There's 3 grays right here and 1 gray right here. So that's 4. 4 over 7 total kittens. And the probability of selecting a female kitten. There's 1 female here, 1 female here. So that's 2 out of 7 total kittens. And then subtract this from the probability of kittens that are both gray and female, which is 1. 1 out of 7. 4 out of 7 plus 2 out of 7 minus 1 out of 7 gives you 5 out of 7. That's about 71.4% chance. Here's an example of addition rule when they are mutually exclusive. A box of chocolates contains 3 milk chocolates, 4 dark chocolates, and 5 white chocolates. You randomly select a chocolate. What's the probability that it is a milk chocolate or a dark chocolate? You want to combine the probabilities of selecting milk chocolate, which is 3 out of the total amount of chocolates, 12, and the probability of selecting a dark chocolate, which is 4 out of the total. 3 plus 4 is 7. 7 out of 12 is about 0.583, 58.3%. Try this similar example. A box of chocolates contains 6 milk chocolates, 2 dark chocolates, and 1 white chocolate. You randomly select a chocolate. What is the probability that it is a milk chocolate or a white chocolate? Pause the video and try this one. When you're ready to check, unpause the video. The probability that the chocolate is either milk or white is about 78%. 7 out of 9 chance. The total amount of chocolates is 9. There's 6 milk, 2 dark, and 1 white. This example is multiplication rule dependent. A basket contains 5 apples, 4 peaches, and 3 pears. You randomly selected to eat 3 pieces of fruit. The first piece of fruit is an apple, the second piece is a peach, and the third is a pear. What's the probability of getting this? So first you want to see how many apples there are. There's 5 of them. 5 out of 12 total fruit. Well, once you eat an apple, there's only going to be 11 remaining fruit. And there are 4 peaches still. If they chose another apple, it would be 4 apples. And then after eating that one, there's going to be 10 fruits left. The probability of getting a pear is 3 because there's still 3 pears remaining in that instance. From there, you're going to find the product of the numerator and the denominator, simplify the fraction, and you get 1 over 22, which is about 4.5% chance. This example is multiplication rule independent. A spinner has an equal chance of landing on each of its 4 numbered regions. You spin 5 times. The first spin lands in region 1 and the remaining spins land in region 3. So for this one, the probability of it spinning and landing on 1 is 1 out of 4. The probability of the other spins landing on 3 is still going to be 1 out of 4 every time. So it's going to be 1/4 5 times, that's 1/4 to the 5th power. 1 over 1024, which would be 0.1% chance. Try this one. A spinner has an equal chance of landing on each of its 4 numbered regions, 1, 2, 3, and 4. You spin 5 times. What is the probability that the first spin lands on region 1 and the remaining spins lands on an even region? Pause the video and try this one. When you're ready to check, unpause the video. The probability that the first spin lands on region 1 and the remaining spins lands on an even region would be 1.6% approximately. The first spin is 1 out of 4. The second through the 5th spins are each going to be 2 out of 4 since there's 2 even numbers there, which you can rewrite as 1/2. Multiply them together, you get 1 over 2 to the 6th power. That's 1 over 64. For a given event A with probability P of A, the complement of that event is not A, and its probability is 1 minus P of A. For example, if you rolled a single cubical die and it came up a 4, the complement of that event is event not 4. In other words, it is the event 1, 2, 3, 5, or 6. The probability of rolling a 4 is 1 out of 6 because there is only one way to roll a 4. There are 5 ways to roll not 4. So the probability of rolling not 4 is 5 out of 6. If you add the probabilities of an event and its complement, the answer is always 1. Which of the following is the probability of not rolling a 6 on a duohexahedron, a 12-sided die? Pause the video and determine which of these answer choices is correct. The answer is 11 out of 12. The probability of rolling a 6 is 1 out of 12. 1 minus 1/12 is equal to 12 over 12 minus 1 over 12, which is equal to 11 over 12. Hypergeometric probability. A class has 8 girls and 4 boys. If the teacher randomly picks 6 students, what is the probability that he will pick exactly 2 boys? We will use the hypergeometric discrete probability distribution. We're going to let n equal 12, the total population. Lowercase n equals 6. That's how many people are picked from population. M is going to equal 4. That's the sample size, which was boys. And then x equals 2. How many boys are picked from the sample? You'll plug these into this formula. It's the combination formula without repetition. So we have 6 times 70 over 924. And that's going to give you that 5 over 11. Or 45%. Remember, capital N is the total population. Lowercase n is the picked from the population. Capital M is the total sample. And then X is the total picked from the sample. Here's another example. A gardener has 13 identical looking tulip bulbs, of which 6 will produce yellow tulips and 7 will become pink. She randomly selects and plants 5 of them and gives the rest away. When the flowers start to bloom, what is the probability that at least 2 of them are yellow? For this one, you'll use that formula multiple times. You want to find the probability of getting exactly 1 yellow tulip and getting exactly 0 yellow tulips. For both, let capital N equal 13 and lowercase n equal 5. To get the probability of getting exactly 1 yellow tulip, let capital M equal 6 and x equal 1. To get the probability of getting exactly 0 yellow tulips, repeat the formula, but this time let x equal 0. Combine the two results and subtract them from 1 to get that complement, to get the probability of getting at least 2 yellow tulips. We'll write out the formula. Notice the only thing that changes here is the value with the x. And then we find the products of the numerators, which becomes 1 minus 210 over 1,287 minus 21 over 1,287. Combine those, and then the 1 becomes 1287 over 1287. You get 1,056 over 1,287. From there, you could simplify it down more by divide each by 33. And you get 32 over 39, which is approximately 82.051%. Here's a binomial probability example. An archer has a 30% chance of hitting the bullseye on a target. What is the probability that the archer will hit the bullseye exactly 3 out of 5 times? To do this, we're going to use the binomial discrete probability distribution. We'll let n equal 5 and x equal 3. The probability p is 0.30. That's the chance of hitting the bullseye, and the complement is 0.70, the chance of missing the bullseye. We'll plug them into the formula. 5 factorial over 3 factorial, 5 minus 3 factorial, times the probability of hitting the bullseye, 0.3 to the third power, times the complement, 0.70, to the 5 minus 3 power. Okay, 5 minus 3 is just 2, so we can rewrite these. And then 5 factorial is the same thing as 5 times 4 times 3 factorial. 2 factorial is the same thing as 2 times 1. The 3 factorials will cancel, and then 4 divided by 2 is just 2. 10 times 0.3 to the third power times 0.7 to the second power. And then this would be about 0.1323. 13.23%. So remember, n is for the total, r is how many there are from the total, and p is the probability of success for each. Here's an example of binomial probability of at least or at most instead of exactly. A quiz consists of 7 multiple choice questions. Each question has 4 choices. A student who forgot to study guesses randomly on every question. What is the probability that the student answers at least 6 questions correctly? Use the binomial discrete probability distribution. Let n equal 7 and x equal 6. We also call it r. The probability p is 0.25. That's the chance of guessing correctly. And the complement is 0.75, the chance of guessing incorrectly. Repeat the formula, but for the second time, you're going to let n equal 7 and the r equal 7. Combine the two results. So if we plug this into this formula, it'll look like this. Okay, we can replace the 7 minus 6's to 1's. And we can replace the 7 minus 7's to 0's. Now, a number raised to the 0 power equals 1, and 0 factorial is also equal to 1. So if we rewrite this, we have 7 times 6 factorial over 6 factorial, 0.25 to the 6th power times 0.75 to the first power, which is just 0.75, and then add the 7 factorials cancel out. You're left with 0.25 to the 7th power times 1. Alright, the 6 factorials will cancel out. Let's go ahead and rewrite it again. 7 times 0.25 to the 6th power times 0.75 plus 0.25 to the 7th power. You'll get about 0.0013427734375. which is about 0.134%. Try this example. Suppose you're going to take a 20-question multiple choice test, but you guess on all the answers. Each question has 4 choices with only one of them being correct. What is the probability of getting 100% correct by guessing? Pause the video and try this one. When you're ready, unpause the video. The N will be 20, the R is 20, and the probability of getting it correct is 25%, 0.25. You'll plug it in to the formula, simplify it down, and then once you calculate this, you would get 1 over 4 to the 20th power, which is a very, very microscopic, tiny number. Now the kind of questions that they'll ask for these are usually the ones where it's a coin flip. What's the probability of getting at least 1 heads, at least 3 tails out of a certain amount of numbers, or a certain amount of flips? Keep going through the slides, look at more videos on worked out practice problems. Try the worksheet and then move on to the next section.